Okay, let's talk for a minute about piezoelectricity. According to the Google Dictionary, piezoelectricity is the electric polarization in a substance, especially certain crystals, one notable one is quartz, resulting from the application of mechanical stress. Okay, let's look at chemistry and dipoles. A molecule in which the concentration of positive electric charge is separated from a concentration of negative charge. That's a dipole. Let's just do a make-believe piezoelectric material here where we have random dipoles, negative, positive, so forth, and both throughout the material. Now, in a piezoelectric material, what will happen is these dipoles will align under compression. Let's say we compress it down that way. You can get an alignment where one side becomes net negative and the other side net positive, causing a current to flow, at least momentarily. It'll charge kind of like a capacitor. If you just hold the pressure on it, it'll stop flowing. Release the pressure and it'll reverse back in the opposite direction. So that's what a simple description of piezoelectricity will look like. Now what I've decided to do is see if I could measure low voltage piezoelectricity in miscellaneous materials. So I made a device for doing that. This is a list of some of the things I'm looking at. It's just random stuff I grabbed around the house, the shop, just see if I can measure any voltage difference across the piezoelectric material or the material I'm at least testing for piezoelectricity. So I built a little device to do this, and I'll show you what I did. I looked at several different ways of being able to test the piezoelectricity in miscellaneous materials. I wanted something that had a horizontal platform so that I could put granular materials on it and they wouldn't fall off. Just so happened, my wife had this never need device here. She uses it for making polymer clay statues. It works the polymer clay, and but she said I could use it as long as I don't tear it up. So what I did is I got two pieces of 1/8 inch thick aluminum bar stock, cleaned them up a little, 1 inch wide, one here and one here. I used double stick tape, like this double-sided tape here, to actually use a piece of duct tape first to protect the platen area here, and then use the double-sided tape on the back of that to hold this bar stock here. And I've got one, on the top part of it, same thing. And when I lower this, you'll notice that this 1 inch bar stock crosses this 1 inch bar stock, so I've got 1 square inch of contact area where I can apply pressure on it. And so I thought, well, this might work, and as it turns out, it actually works pretty well. You could probably come up with another device like a vise or something, but I had this around, so I thought I'll use it. So that's what I did. Now, what I'm going to do is show you how I made the connections back here. I can do that right now. Actually, this is a voltometer. I've got it on DC volts on the lowest or the highest sensitivity there, which looks like 200 millivolts, I believe. And it's real sensitive there. And I've got a red lead connected here to this top bar, and black lead connected there, and they're connected to the negative and positive inputs on the voltometer. The reason I wanted to make sure I had that consistent was because if it's something that's really piezoelectric, when I turn it upside down, the polarity should change. So if I repeat it, so that's why I did that. So we're going to take a look at some miscellaneous materials, and what I'm going to do is go slow with the first couple of them, then just speed it up so you don't have to be bored with watching all that. Then we'll summarize what I found and focus on those materials which look particularly interesting, because most of them don't, but some do. So I'd like to make one other comment. The platens on this never need device were electrically insulating, a type of some kind of engineering plastic. So this device wouldn't short circuit everything through the device itself. But adding the duct tape helped ensure that. So we don't want your any voltage you generate just to be short-circuited through the device, whether it's a vice or something like this. The thing I need to point out is if I have nothing in there, of course both these are conductors, it just shorts itself out. You get basically zero. This is a piece of vinyl flashing material like I got from Lowe's or Home Depot. Let's put that in there. So it should be PVC. Well, it's pretty good response on that. Let's turn it over. Definitely a pretty good response on that. How about that? That's been the best yet. Well, this is a piece of 100 grit 3M sandpaper, aluminum oxide. We'll put that in there, grit side up, and see what it does. Not much of anything. Turn it over. Not much of anything. Okay. This is this Winto green mints. When you crush them in the dark, you get a triboluminescent flash. Let's put one in there and see what it does. Most of these piezoelectric things, to really get the effect, is you're really depressing it and compressing it rather than crushing and destroying it, like you might do with this in a claw holder in the dark to measure something. I don't really measure anything that way. I don't know if I can put enough pressure on this the way it's made to crush that. It's not doing anything. It's broken. We'll put that in like that. See what it does. Nope, nothing. Very little anyway. Okay, this is this lump candy. I don't know if they're large crystals or just compressed sugar. I don't really know. We'll put a little pressure on that and see if we measure anything. I can quit making a mess here. I'm just putting a little pressure on it. And that's not, when it crushes, you get a number. There's no question about that. But you don't see it until it totally disintegrates. Let's try a little ordinary table salt, which is sodium chloride. Let's see what we get. Okay, ordinary table salt. We actually measured something. That's a surprise. Not a huge amount. Repetitive squeezes doesn't do as well as that first one. Not sure what's going on there. Now we're going to try a little just coarse black ground pepper. Oh wow, look at that. That's the best thing yet. Now, who would have guessed? Okay. This is some sand, which I'm sure is mostly quartz. It's what they use for making mortar and kids play sand in this area. Probably comes from what they call Columbia sand down in the middle of the state. We'll sprinkle a little on there, see if we measure anything. Of course, the situation with the sand is going to be like with the sugar. It's impossible to orient the crystals in any particular way. Okay, we'll try that, see if we measure anything. Well, yeah, you do. How about that? You do measure it. Now, you would think any crystal orientation would just be random. So, definitely you can measure something like that with the quartz sand. Let's try a piece of black electrical tape. Most likely is vinyl. It's PVC. Anything with a electronegative atom in it, a molecule like fluorine or chlorine, is probably going to do better on a lot of stuff. See if I can just lay that on there like that. Let's see if that measures anything. Oh, yeah, it does. How about that? I'll have to slow it down and see how high that got, but not too bad. Okay, the multimeter's on 2 volts DC. Let's, just for the heck of it, this is a 1.5 volt AA battery. Let's put that in there. We're not going to try to crush it, but yep. It's a 2 volt scale. Let's put it on the 20 volt scale. 1.5 volts, yeah. Okay, 1.6. There, and that's the 2 volt scale. And if I move that up to 200 millivolts, it's over range. So anything that was getting us a 1 like that was really over range. It was higher than we were able to measure with everything on the 200 millivolt scale. The PVC electrical tape I checked when I first did this work, reviewing all these different materials for piezoelectricity, was the Scotch brand 700, just vinyl electrical tape. I'm going to repeat that, but I'm also going to take a look at this, what's called friction tape. Friction tape used to be used for electrical work. I guess it still is used by some, more or less made with an adhesive on a cotton fabric. I'm not sure what's in here. I'm going to open it up and we'll take a look at this to compare it. Okay, I've slowed this down so you can get a better look at it. PVC vinyl electrical tape face down. We always get a better reading when you release the pressure than pushing it down and compressing it. Got a positive 1.8. So what I'm going to do next is flip it over, put the sticky side up on the top bar, and we'll try it like that. But and see if it reverses. Okay, it did. It went to a minus negative. Excuse me, it went to a minus 1.3. So it did reverse when I flipped it over. How about that? Okay, now I'm going to try the friction tape. Let's take a look at that. This is definitely different. It feels like it's sticky on both sides. I think it might be. So we'll put it, what's the downside, the side against that, down here. See what it does. Okay, what was pointing down into the roll, that side, is down here. Not seeing much of anything on that 2 reading. Let's put it on the what looks like 200 millivolt reading. Well, you measure something here. It goes negative when I release it. Let's turn it over and see if it goes positive when I release it. Yep. It is positive when I release it. So that's piezoelectric too. Looks like it. Very interesting. Okay, here's the vinyl siding again, one orientation. Push down on it, hold it steady, and release it. It instantly goes positive. Flip it over. Instantly goes negative. I'd say that is piezoelectric. I bought some better quartz crystals off Amazon than the ones I got from that gift store in the state park. Most of them are these classic hexagonal shaped quartz crystals. I've learned some more about these quartz crystals since I started doing this. We'll go ahead and put this in there and we'll see what it does, but I'll show you. Even though quartz is one of the better known piezoelectric materials, and this device, measuring it this way, get almost no voltage, minuscule amount of voltage. Which is kind of interesting to me. So I looked into this a little further. Let's turn it around, different side. I'll try one more side. Okay, I'm going to try to stand it on end. There's not much contact area, minimal. Okay, that's about the best we're going to do with one of these quartz crystals. I've already looked at some others, so just showing you what that looks like. One other thing I wanted to mention, quartz is known for being a very piezoelectric active material. I've learned since I started doing this project that to get the maximum effect, you have to cut the crystals at a particular angle. Haven't really found out yet what that angle is. It has to do with the way the molecules, the silicon and oxygen, are oriented there in that crystal pattern. But I thought maybe someday in the future I might try that, cutting one of these crystals at an angle and make little wafers cut at various angles and see if I could see that effect. But like this, you don't really see it, at least not pressing that way. So maybe that's for a future project, we'll see. I had two major objectives doing this project. One of them was to come up with a device that would allow me to measure very low levels of piezoelectricity in assorted materials. And I think this does that pretty well. Luckily, my wife had this available for me to use. You could use a vise or even maybe a pair of pliers to do something similar. But I wanted to make a few comments about what I did. I wanted to just test all kinds of things, not things that were known for being piezoelectric, but just see if ordinary household materials could demonstrate any, even a small piezoelectric effect. One thing to keep in mind when we look at this data was something that was piezoelectric. This is a piece of Lexan, but let's just assume that it was. Normally, if you compress it, you would tend to rearrange the dipoles in there such that one side becomes more negative, the other side more positive. You might get a short burst of current either when you press it or when you release the pressure. And but other effects could also be going on. There's something called an electret, and what that is something like a polymer. It could be this. If you heat it up above its glass transition temperature and put an intense direct current electric field across it, then cool it down, you can orient those dipoles and then freeze them in place so that there's that net dipole orientation just left in the structure. So that one side's net positive, the other side's net negative. Now, that's actually used commercially to make microphones. You can use polyvinylidene fluoride, PVDF, for a stable polyester electret like polyethylene terephthalate. It's only stable for maybe 6 months, but you can do it. But they're also used to make some of these electrostatic filters for your HVAC ducts and what have you that'll help collect dust particles. If you were to do that, let's say we just made this electret, space charges, just debris in the air, dust that has either negative or positive charge, that would tend to be attracted to that surface charge there and form surface charges on it, tends to neutralize that effect over time. And early years ago in some of my work with electrostatics, I found that you could spray a high voltage charge on a surface, say a polyester film, and if it was dry, not real humid, it could stay there for 3 weeks or more. And so it can be very stable. Now, there's another thing that could be going on. You know, a lot of plastic materials, other materials, if you rub them, you get a triboelectricity. In other words, that friction tends to build up a charge on the surface, depends on the relative dielectric properties of each of the materials. So when we're looking at very, very low voltages here, some of this I wasn't sure if it was a electrode effect or if it was a triboelectric effect or if it really was a piezoelectric effect. To me, the real determining thing is whether or not I could squeeze it, release the pressure, and consistently, repetitively see that charge, and then flip it over and see the polarity reversed. I felt like if I could do that, it probably really is demonstrating a level of piezoelectricity. I've summarized the results of my testing of all these different materials in this Excel spreadsheet. What I've done is highlight the ones in yellow that really showed little to no piezoelectric effects. The ones in green showed the most. And so what I'm going to do is just quickly kind of run over some of this. Post-it note, Kevlar 3x5 cardstock, HP premium photo paper. Again, I was just grabbing whatever I could find around here. What I'm going to do is scroll through this slowly, so if you're interested in looking at any of these, you can just slow your video down and take a closer look. The PVC vinyl flashing actually was a little interesting. It's definitely worth retesting. McAllister's Deli Cup, which is most likely polystyrene, appears to be piezoelectric. Just cutting a piece out of the side of the cup and testing it. Some of these other things had a little bit of it. It's probably worth taking another look at. This Staples Rewards card, which like any credit card, most likely made out of vinyl, appears to be piezoelectric. A lot of stuff like fabric I didn't see much in sugar crystals and what have you. Even though wintergreen lifesavers showed triboluminescence, I didn't really see any piezoelectric effect, at least in the way I did this. This level or window blind material, I'm not sure what the polymer is there. I think it might be a type of polyester. I'm not totally certain. Well, it's interesting, the quartz sand actually showed a little bit. Even though the sand crystals, quartz crystals, couldn't possibly orient all in the same direction, there did appear to be a little bit. Of course, I couldn't turn it over to check it. I even checked pepper, of all things. A quartz crystal, I mentioned I found out later that quartz crystals have to be cut a certain way to really show that effect. It's known for being piezoelectric. The most interesting thing by far that I looked at in this work was this PVC electrical tape with the sticky side down. Of course, that really doesn't matter. It just affects how the polarity shows up on the multimeter. What I'm going to do is take another look at this PVC electrical tape, and we'll just take a little closer look at that and see what we can see, because it by far had the most measurable effect the way I did this. I hope you enjoyed this and maybe got something out of it. If you did, please like the video and subscribe. I would really appreciate it. Check out our other links. Check out my all anisotropic videos links at the end. And we've got over 150 videos now, so I think you'll find them very interesting.